If HA is almost negligible, then answers will slightly change. No. Okay, this is a very good question. I am trying to test you with. Let me draw a fresh line. Look at now. What is the question like? Let me read the question. Hope I think by this time everyone is able to understand my handwriting. Hmm. Find the length of the plane mirror so that a person looking into the mirror is able to view the complete image of rear wall of eye edge. There's a wall. So what this person he should able to see the complete wall, the image of the wall he should able to see. See, if he turns, he can see the wall. What is the condition? What should be the length of the mirror so that the complete wall should be visible through the mirror? What should be the length of the mirror? Earlier we discussed about himself, no? For the person himself. So now we have changed a little bit condition here. What is your approach? I think I should allow you to really think on this particular problem. What should be the generalized approach? The rays emitted by the top end of the wall and the bottom end of the wall after reflection with the mirror should enter into the eye. Then only is able to see himself. So then only is able to see the wall completely. I think this is a condition. Let me take you to the diagram. No, what your physics teacher is trying to stress in a very simplified, the ray emitted by the bottom of the wall after reflection should enter into eye. The ray emitted by the top end of the wall after reflection with the upper end of the mirror should enter into the eye. I think if this condition is satisfied, then what this person will commit? I'm able to see the total wall which is behind me. How to do such problems? See, you can lot of maths will be involved. So nothing but what happened? The reflected ray should enter into eye, no? So where the this particular mirror, there's a mirror. What this mirror does, it should form the image of wall, and that image should be visible for the person. So I will take a totally a simplified approach. Hmm? So this you can, if you are interested, you can fight with the mathematics here. So we'll just go for a very simplified approach. We need not to struggle. So if this is the wall, okay, then there's a mirror. Let me show that mirror here. Oh, yeah. Now see this. There's a mirror. So where do this mirror will form? Its image will be formed here at equal distance. I think I'm very sure these two lengths will be equal. So this length is equal to L. This length also should be equal to L. And what is the H? Okay, what is this? There's a wall. What is this? There's the image of wall formed by mirror. And the person, let it be somewhere here. Okay, the rays emitted. Proportionally, let me adjust the let me adjusting. Okay, this is the mirror. Yeah, no. Okay, this I know. The person I should enter is I. Okay, here let me take the so this length, let it be x, this is y, theta 1, theta 2. We know this distance. This is what? Eta L. And this is the total height of the mirror. So let me write it. This is h1, this is h2. And this should be equal to what? H again in turn. H1 plus h2, in fact, must be equal to h. So what was our question? The length of the mirror. What is the length of mirror? Length of the mirror will be x plus y only. So this is the mirror. But sir, you can ask question, sir, what you made something like, see this, as if now the rays emitted by the wall after reflection at the end of the mirror will enter into eye. This rays as if they are coming from here, no? Both are same. So I'm just making the image. I'll bring the image of the wall here. Let the rays emitted by the image. What are this? This ray, the rays emitted by the also like these are the reflected rays, no? So from where do it should come? It should be diverging from the image. So I'm bringing here. So what is this? This one, this is the image of wall formed by the mirror. This is one approach. You see, we are supposed to work out here. Here, lot of maths is involved. We have just got a simplified approach here. X plus y is what? Length of the mirror. Let me write symbols. A, B. Got it now? Okay, just let's write. Look at the triangle. So which triangle you have to look at? You have to look at this triangle. There are two triangles, similar triangles are there. This is one similar triangle, and this is also a similar triangle. So tan theta 1 should be equal to x by eta L should be equal to h1 by L plus eta L. See things carefully. This length is L because object distance should be equal to image distance. The wall was at a distance L from the mirror. So its image should also be at a distance L. So what can be this total length? L plus this length is eta L. Okay, we wanted h1. So the L will get eliminated. This will become, we wanted x, no? So x should be equal to h1 eta by 1 plus eta. Similarly, lower triangle, tan theta 2 should be equal to y by eta L, h2 by L plus eta L. Now, what is this equation from where I brought it? So looking at this triangle. Tan theta 2 opposite h2 adjacent, how much adjacent? Adjacent will be L plus eta L. Similarly, looking at this two are similar triangles. So tan theta 2 here, opposite is y, adjacent is eta L. What is the length of the mirror? The length of the mirror is should be equal to how much? H1 plus H2 eta by 1 plus eta. What is H1 plus H2? Should be H. Okay, some equations are there. We should able to now interpret. What do you mean by that? Where I took I, look at the position of I. It's independent of position of I, no? Because it's not coming something like a what is the height of the mirror. This length is not coming. The final answer, it is independent of height of the mirror. At what height the mirror located from the ground, or what is the position of eye irrespective of that. If I is exactly the midpoint, this is like a room, no? Eta L and L we took it. Suppose if I is exactly the midpoint, then eta will become 1 by 2. Substitute 1 by 2. Then you get some length of the mirror. Means where between, so the length of the mirror needed, what happen? It depends upon the position of eye between the wall and the mirror. So usually what happen? It will be just lying. So what is this entire question will be like? Is it a vertical wall? No, this is like a horizontal wall. There's like a width actually, to be frank. And the mirror is kept and the person is the different. So this will be the ground. This is not the ground. That's why I didn't try this as a ground. Little bit some conditions are here. Instead of this, like a, or no, sir, let it be ground. Okay, no problem. Still you can manage. If exactly the midpoint between the wall and the mirror, so then put eta equal to 1 by 2. Then look at the length of the mirror. So in the diagram, I'm showing that the person is on the like some sort of a ground, no? Okay, now if it's exactly the midpoint between the wall and the mirror, okay, then put eta equal to 1 by 2, then you get the length of the mirror. So shall I say that as he changes his position, eta will change. The length of the mirror requires also will change.